Hello there, and welcome to Deep Space Sleep. I'm really glad you're here. Maybe your day felt crowded and bright in all the wrong ways. And now you're finally ready for darkness that doesn't feel heavy. Or maybe you're someone who finds comfort in the night sky, in knowing that when the world quiets down, light still moves gently through the atmosphere, rising in colors, drifting in patterns, and glowing in ways that feel almost alive. Either way, this moment is for you. There's nothing you need to decide or fix or think through. Let the night open around you. Let your shoulders loosen. Let your breath slow, as if you're standing under a wide northern sky where cold air is still, where stars sharpen their edges, and where the first faint colors of an aurora begin to gather at the horizon like a soft whisper. In this video, we're exploring the calm light that appears only after the sun sets, not the storms, not the science headlines, but the quiet, drifting beauty that fills the night. The green curtains that rise in slow waves, the red arcs glowing high above, the thin violet edges shaped by magnetic fields, the night glow that brightens the sky even when everything seems dark, the moon halos, the meteors, the soft reflections on snow and ice. You'll hear 100 gentle facts, some about the auroras you already know, others about the faint, hidden lights that most people never notice, but that have always moved across the sky in silence. If this helps you rest, you're welcome to subscribe whenever you wake. It helps others find these quiet moments too. For now, let the night sky glow softly around you. Let's begin. Sunlight fading into gentle twilight begins as the sun drops below the horizon, sending its final rays through more of Earth's atmosphere. The thicker path scatters blue light first, softening the sky into deeper, warmer tones. Molecules, dust, and faint aerosols catch the low-angle sunlight and bend it into long gradients that shift gradually across the sky. Daylight doesn't disappear instantly. It thins, stretches, and dissolves into layers of calm color. Birds quiet their calls, insects move more slowly, and the air itself seems to settle as temperatures begin to fall. Twilight becomes a bridge, not a boundary, the moment when brightness gently hands itself to darkness. And as light continues to fade, the atmosphere begins preparing for the next subtle change, allowing particles drifting into shadowed air to shape the earliest hints of night illumination. Particles drifting into shadowed air play a quiet but important role in how the night sky begins to glow. As sunlight weakens, dust, grains, sea salt, volcanic aerosols, and microscopic droplets remain suspended in the cooling atmosphere. These particles scatter the last remaining traces of light, making the sky appear softer and more luminous than it would in pure darkness. The glow is faint, almost imperceptible, but it gives color and texture to the early night. These particles also act as tiny platforms for chemical reactions that will later generate night glow. As temperatures fall further, the air becomes clearer and the scattering becomes more delicate, allowing shapes on the horizon to blend gradually into shadow. And in this gentle dimming, the atmosphere prepares to reveal the first wavelengths stretching across dusk light that continues to travel even after the sun is gone. First wavelengths stretching across dusk appear when long, low-energy colors, deep reds, warm oranges, and muted purples linger in the sky long after shorter wavelengths have scattered away. These faint colors travel farther through the atmosphere, bending around the horizon in a slow, graceful sweep. Even as the sun disappears completely from view, its longest wavelengths continue illuminating the upper air like a fading brushstroke. The effect is soft, almost dreamy, giving the sky depth even as darkness rises. This lingering light interacts with thin atmospheric layers, bouncing subtly between them and creating gentle gradients that shift moment by moment. Stars begin to appear through the thinning color, easing their way into the sky. And as these final wavelengths fade, the atmosphere transitions toward deeper processes, allowing night glow forming at the edge of darkness to become the next quiet light that fills the sky. Night glow forming at the edge of darkness is one of the atmosphere's softest and most constant sources of light. Long after twilight fades, the upper air continues to release energy stored from the day. Molecules of oxygen, sodium, and hydroxyl react quietly in the thin, high atmosphere, creating faint green, red, and yellow glows. This light is subtle, far dimmer than auroras, but strong enough to prevent the night sky from ever becoming completely black. The glow forms in thin sheets hundreds of kilometers above the ground, drifting slowly with atmospheric tides and waves. It's a gentle reminder that the sky is never fully still. Even in darkness, chemistry continues in soft, rhythmic pulses. Night glow also reveals the movement of the upper atmosphere, tracing winds that circle the globe silently. And as this delicate radiance settles, it blends with cooling air, shaping faint sky colors that deepen the night's quiet palette. Cooling air shaping faint sky colors happens because temperature drops change how light scatters and how moisture forms in the lower atmosphere. As air cools, it becomes denser and steadier, reducing turbulence and letting colors soften into smoother transitions. Tiny droplets begin to form, adding a subtle haze that bends light into muted pinks, violets, and soft blues. These colors don't come from direct sunlight, but from the atmosphere's lingering ability to bend and diffuse whatever light remains. The cooling also strengthens atmospheric stability, allowing layers to separate cleanly, each one scattering light differently, producing gentle bands of tone in the sky. The horizon deepens first, then the zenith, until the entire dome becomes a calm gradient from dusk to night. And within this cooling stillness, the stage is set for the next transformation, beginning the journey into the deeper lights of the night. Molecules releasing soft photochemical light create one of the quietest forms of natural illumination. After sunset, oxygen, nitrogen, and hydroxyl molecules in the upper atmosphere slowly release energy absorbed during the day, emitting faint glows in green, red, and near-infrared wavelengths. This process, called chemiluminescence, happens high above storms and weather so high that the air is thin, cool, and peaceful. To the eye, this light appears as a subtle wash, too soft to notice directly, yet strong enough to prevent the night sky from ever becoming fully dark. It forms a drifting veil across the upper atmosphere, rising and falling with gentle atmospheric tides. As these molecules finish releasing their stored energy, the surrounding air becomes even more stable, allowing upper air atoms entering excited states to begin their own quiet contribution to the night's glow. Upper air atoms entering excited states begin to glow when they collide with energetic particles or absorb wavelengths from the fading day. In the thin mesosphere and thermosphere, atoms like oxygen and nitrogen float widely apart, so each interaction happens slowly and silently. When an atom absorbs energy, it holds that energy briefly before releasing it as a faint pulse of light. Tiny, gentle flashes spread across the sky at altitudes far above normal clouds. These pulses combine into broad, soft glows that drift around the planet like an invisible river of color. Because the air is so thin, the light spreads smoothly, without flicker or harshness. This high-altitude glow contributes to the overall calmness of the night, helping the sky settle into calm transparency as darkness deepens and clarity returns to the air below. The sky settling into calm transparency occurs as particles, turbulence, and lingering daylight fade away. Cooler air near the ground becomes still, allowing dust and moisture to sink slowly, leaving the upper layers clearer and more open to starlight. Temperature gradients smooth out, reducing shimmer and distortion. The result is a sky that feels wider, deeper, and more restful. This transparency is what makes distant stars appear sharper and planets glow steadily instead of twinkling. It is also the phase when the atmosphere becomes a perfect lens, passing light through with minimal interference. Animals respond quietly, nocturnal creatures begin moving, and diurnal ones fall into rest while the landscape becomes wrapped in a soft, even darkness. As the transparency grows and the last traces of daylight vanish, distant starlight returning as brightness fades becomes the next gentle transformation in the night. Distant starlight returning as brightness fades marks the moment when the cosmos gently reclaims the sky. As twilight drains away, stars that were hidden in daylight slowly emerge, one by one, revealing layers of depth that stretch across unimaginable distances. The atmosphere, now calm and transparent, allows their light to travel undisturbed, carrying stories from star clusters, nebulae, and galaxies scattered across the universe. The faintest stars appear last, shimmering with a steady softness shaped by the stillness of the air. This returning starlight gives the night a quiet structure, anchoring the darkness with distant points of calm, ancient light. And as more stars emerge, the sky shifts once again, preparing itself for something even more delicate. Atmosphere preparing for Aurora's first stir as invisible forces begin gathering far above. Atmosphere preparing for Aurora's first stir begins long before any visible color appears. High above the surface, Earth's magnetic field starts guiding energetic particles toward the poles, creating invisible pathways that curve gracefully into the upper atmosphere. These charged particles travel millions of kilometers from the sun, then slow and spiral as they approach Earth, drifting into regions where oxygen and nitrogen wait quietly. Subtle electrical currents begin to form, lighting up sensors long before they touch the eye. The air at auroral altitudes cools and stabilizes, like a stage waiting for curtains to open. Even before the first glow appears, the sky feels different, emptier, deeper, expectant. And then, when conditions align, the first faint green begins to rise at the horizon, marking the quiet beginning of the aurora's unfolding dance. Solar wind flowing in gentle waves begins its journey at the sun, where streams of charged particles drift outward in broad, continuous currents. Although the word wind suggests force, most of this flow is quiet, expansive, and thin, so faint that a person in space wouldn't feel it passing. These particles travel across millions of kilometers, spreading like a soft breath through the solar system. When they reach Earth, the magnetic field slows and shapes them, guiding their movement into elegant arcs around the planet. Only a small fraction slips toward the poles, but even that small portion carries enough energy to ignite the aurora in calm, shimmering color. The solar wind arrives in rhythms, sometimes steady, sometimes slightly stronger, always connected to the distant pulse of the sun. And as these gentle streams approach Earth's boundary, they enter the protective embrace of Earth's magnetic field, guiding soft currents night after night. Earth's magnetic field guiding soft currents acts like an invisible shield, redirecting charged particles into safe, controlled pathways around the planet. Instead of striking Earth directly, the particles slide along the magnetic field lines, curving toward the north and south poles in smooth, spiraling motions. These movements happen silently, thousands of kilometers above the surface, where the atmosphere is thin and still. The magnetic field bends and channels the particles like a soft current flowing down a river, shaping the first steps of auroral light. It also protects the planet from stronger solar bursts, dispersing energy across vast distances. The field itself is constantly moving, drifting slightly each year, shifting in slow, geological time. As these guided currents descend along the poles, they prepare the upper atmosphere for the next stage. Charge particles traveling along field lines until they meet waiting atoms that will soon begin to glow. Charge particles traveling along field lines follow narrow magnetic pathways that funnel them deep into Earth's atmosphere. As they move, they spiral gently, losing energy in soft pulses rather than sudden impacts. These particles come from both steady solar wind and occasional bursts from the sun, but once they enter the magnetosphere, their path becomes calm and predictable. When they reach auroral altitudes between 100 and 300 kilometers above the surface, they begin colliding with oxygen and nitrogen atoms. Each collision transfers a bit of energy, exciting the atoms and preparing them to release light. The entire process unfolds in thin layers, shaped by pressure, temperature, and magnetic curvature. From the ground, nothing is visible yet, but deep in the upper atmosphere, the first quiet glow is forming. And as these particles continue downward, they flow toward regions specially shaped for light, the polar regions opening to nightlight as Earth's geometry welcomes them in. Polar regions opening to night light allow charged particles to enter the atmosphere more easily than anywhere else on Earth. Near the poles, magnetic field lines curve downward, creating natural gateways where solar energy streams can interact with atmospheric gases. These regions remain dark for long periods during winter, giving auroras a wide canvas to appear on. The stillness of polar nights, cold air, calm winds, deep silence creates ideal conditions for auroral shapes to flourish. Here, the sky feels closer, clearer, and more open to faint glows forming above. The polar atmosphere is also thinner, allowing collisions between particles and atoms to release brighter colors that drift across the horizon. Snow and ice reflect the glow, amplifying its softness. And waiting quietly in these high, cold altitudes are atmospheric gases waiting to glow, each ready to release its own color into the unfolding light. Atmospheric gases waiting to glow include oxygen, nitrogen, and trace elements suspended in the thin upper air. When charged particles arrive, these gases absorb energy in calm, silent interactions that take place molecule by molecule. Oxygen produces green and red light, depending on altitude, while nitrogen creates purples, blues, and pinks. Each color forms slowly, requiring precise temperatures, pressures, and energy levels. Before they glow, these atoms exist in stillness, drifting in near weightless layers above the world. Their illumination is not forced, it is released gently. As collisions begin, tiny pulses of color appear, spreading across the sky in waves of soft brightness. This is the moment the aurora comes alive, transforming invisible processes into visible beauty. And with this quiet ignition, the night prepares for deeper colors and wider motions still to come. Electrons spiraling into calm arcs descend along Earth's magnetic field lines in smooth, helical paths. Instead of falling straight, they twist gently, slowed and shaped by electromagnetic forces that guide them toward the polar atmosphere. These spirals form because electrons respond to magnetic curvature, creating graceful loops that narrow as they approach denser air. During this journey, they shed small amounts of energy, preparing for the moment when they will collide with atoms waiting below. The movement is silent, invisible, and constant, an elegant dance happening far above clouds and weather. Each spiral brings electrons closer to the thin region where auroral light begins. Their motion forms the earliest outlines of auroral structures, like unseen brushstrokes drawing paths for color. And as these electrons reach their final descent, their curved trajectories begin to take shape as magnetic curtains forming overhead, setting the stage for the first visual traces of the aurora. Magnetic curtains forming overhead appear when countless electrons stream into the atmosphere at once, shaping long, vertical planes of light. These curtains align with Earth's magnetic field lines, creating towering sheets that ripple gently across the sky. From the ground, they look like soft drapes hanging from space, shimmering as if stirred by an invisible breeze. Each curtain contains millions of individual collisions between particles and atoms, yet the result feels unified and calm. The structure forms slowly at first, outlining faint bands of green or red, before deepening into brighter folds. As energy flows through these magnetic lanes, the curtains sway in subtle rhythms, responding to changes high above Earth. The movement is delicate, steady, and mesmerizing. And from these luminous sheets, the next stage begins to appear: aurora, beginning in thin, quiet bands that hint at the full display still forming in the darkness. Aurora, beginning in thin, quiet bands, often marks the earliest visible stage of a night's display. These bands form when only a small portion of energetic particles reaches the atmosphere, creating narrow strips of pale green or pink light. They stretch horizontally across the sky, sometimes faint enough to be mistaken for distant clouds. But unlike clouds, they brighten from within, glowing softly as collisions increase. The bands drift slowly, rising or falling as magnetic conditions shift. Their calm appearance hides the complex interactions happening above streams of particles, meeting layers of oxygen and nitrogen in silent, organized waves. These early bands act like gentle invitations, signaling that the aurora is waking. And as the light strengthens, the process becomes more intricate, leading toward light emission starting atom by atom as the sky begins its luminous transformation. Light emission starting atom by atom is the heart of the aurora's quiet glow. When energetic particles finally collide with atmospheric atoms, those atoms absorb energy, hold it briefly, and then release it as tiny flashes of colored light. Each emission is microscopic and silent, but millions occur every second, merging into visible ribbons that drift across the night. Oxygen emits green at lower altitudes and red at higher ones. Nitrogen produces violet and deep blue. The pace of these emissions depends on temperature, density, and magnetic conditions, creating a pattern that feels both random and perfectly organized. The overall effect is smooth and fluid, even though each glow begins from a single, excited atom returning to its calm state. And as these countless atoms continue releasing their quiet pulses of color, the process becomes sustained and rhythmic, energized particles humming through silence far above Earth. Energetic particles humming through silence is not a sound we can hear, but a description of the steady, constant flow of electrons and ions entering the upper atmosphere. Their movement creates faint electrical currents that drift along magnetic pathways with remarkable smoothness. Each particle carries energy from the sun, energy that has traveled across space only to unfold in calm glimmers of color in Earth's sky. The humming is metaphorical, a feeling rather than a noise. The sensation of something active yet peaceful, dynamic yet soft. As these particles accumulate, the aurora brightens and expands, forming curtains, spirals, and waves. The night sky becomes a slow-moving tapestry, shaped by forces too gentle to disturb the air below. And as the flow continues, the aurora reaches its full expression, ready for the next part of its story to unfold. Oxygen glowing in pale green is the signature of most auroras. A soft light released when oxygen atoms, about 100 to 150 kilometers above Earth, absorb energy from incoming electrons. After collision, each atom holds that energy for a quiet moment before releasing it as a gentle green photon. The glow spreads through the sky in smooth bands or drifting curtains, forming shapes that ripple with slow, dreamlike motion. This green light feels both vivid and soft, bright enough to illuminate snow but gentle enough to calm the night. Because oxygen glows at a specific wavelength, the color remains pure and steady, shifting only in intensity as particle flow increases. And when the energy reaches even higher atmospheric layers, the same oxygen begins its next quiet transformation. High-altitude oxygen forming red veils that drift far above the green. High-altitude oxygen forming red veils occurs around 200 to 300 kilometers above Earth, where the atmosphere is thin, the air is cold, and collisions happen slowly. Here, oxygen atoms release their stored energy in a much longer, gentler transition, producing a deep crimson glow. These red auroras often appear as faint tops of green curtains or as broad, hovering arcs that stretch across the upper sky. Their movement is subtle, slow pulses, soft flickers, delicate waves drifting through the darkness. Because the air at these heights is so rarefied, the red glow can linger, hanging in place like a quiet halo. This high-altitude red is rarer to see, requiring calm air, strong particle flow, and clear darkness. And as the red veils drift downward, they begin blending with another soft light nitrogen, creating purple fringes at the boundary where colors meet. Nitrogen creating purple fringes happens when energetic particles collide with molecular nitrogen lower in the atmosphere. These collisions release light in the violet and deep purple part of the spectrum, forming thin outlines around green or red auroral structures. The effect is delicate, like the faint edge of a brushstroke, shimmering for a moment before dimming again. Nitrogen emissions often mark the boundaries where aurora grows more active, where electrons enter the atmosphere more quickly, or where the magnetic field bends sharply. The purple light mixes with surrounding colors to create transitions that look almost painted, gentle and fluid. Sometimes the fringes appear only for seconds, flashing in pulses that trace the motion of charged particles. Other times they form continuous ribbons that sway beneath larger arcs. As nitrogen completes its quiet glow, the light deepens and changes again, giving rise to blue aurora, shining close to Earth, where higher energy collisions gather. Blue aurora, shining close to Earth, appears at lower altitudes, typically below 100 kilometers, where energetic particles strike nitrogen molecules with greater intensity. These collisions produce light in blue and indigo wavelengths, creating a glow that feels cooler, sharper, yet still gentle in motion. Because the lower atmosphere is denser, the light forms crisp edges and more defined shapes, often appearing at the base of larger auroral curtains. Blue auroras can flicker quickly, responding to rapid changes in particle energy. Their color blends quietly into nearby greens or purples, creating smooth gradients that shift as the aurora evolves. On snow or ice, blue aurora casts a soft, ethereal glow that seems to ripple across the ground. And within these rare moments of intense yet calm light, another delicate blend emerges: rare yellow and white blends, forming from the mix of overlapping emissions and changing atmospheric conditions. Rare yellow and white blends forming occur when multiple wavelengths appear together: green from oxygen, red from high-altitude oxygen, and blue or purple from nitrogen. When these colors overlap in just the right balance, they create soft gold, pale lemon, or even white auroral patches. These hues are uncommon because they require precise particle energies and stable atmospheric layers. Yellow auroras sometimes appear near the edges of bright green curtains, where blue or red briefly mixes into the glow. White auroras form when the overall brightness becomes so strong that the human eye blends all wavelengths together, creating a pale, luminous wash across the sky. These blends feel delicate and unusual, appearing like quiet lanterns moving in the darkness. And as these rare colors fade, they prepare the sky for the next sequence of drifting hues still to come. Colors shifting through thin magnetic ribbons emerge when energetic particles move along narrow magnetic field lines, creating bands of light that twist and sway with the flow of charged currents. These ribbons can change hue as oxygen and nitrogen respond differently to the incoming energy, causing transitions from green to purple or red to blue in slow, gentle gradients. The movement feels almost alive, expanding and contracting like breath. Because the magnetic field shapes the path of every particle, the ribbons curve across the sky in elegant arcs. Sometimes they appear faint, like soft brushstrokes across darkness. Other times they brighten into vivid flowing lines. And as these colors drift with the field's quiet pull, they begin folding into more recognizable forms: green curtains folding in gentle rhythm just beneath them. Green curtains folding in gentle rhythm form when auroral light gathers into broad sheets shaped by Earth's magnetic field. These curtains ripple like fabric, rising and falling as particle intensity shifts across the sky. The soft green glow comes from oxygen atoms releasing stored energy, each transition creating a tiny point of light that blends into the glowing plane. The curtains can drift slowly, moving like waves passing through calm water, or pulse in subtle patterns that feel almost musical in their timing. Their folds change shape as invisible winds move through the upper atmosphere, stretching the curtains into long arcs and then relaxing them again. Standing beneath them feels like watching a silent dance, light flowing with purpose, but no sound. And above these moving layers, another color begins to shimmer, red arcs shimmering above the horizon where colder, thinner air allows delicate crimson light to form. Red arcs shimmering above the horizon appear when high-altitude oxygen emits a deep red glow, often forming quiet, stable bands that stretch across the upper sky. These arcs hang higher than the green curtains below, floating like soft, distant veils. Because the air is thin at these heights, the red light takes longer to form, creating a slower, more lingering radiance. The arcs may brighten gradually, then fade into a gentle haze that blends with the surrounding darkness. Their motion is minimal, slow ripples, faint pulses, subtle expansions as magnetic energy shifts. Sometimes, the red arcs appear almost disconnected from the rest of the aurora, like a separate layer of sky glowing on its own. And as the red fades or intensifies, the colors begin to overlap and mingle, mixed color bands weaving slowly where different wavelengths meet and drift together. Mixed color bands weaving slowly form where green oxygen light blends with nitrogens, purples, and blues, creating a tapestry of shifting hues. These bands often appear where field lines bend or where particle streams fluctuate, causing colors to overlap in smooth, flowing motions. The blending can create soft gradients, with shades that seem to melt into each other as if stirred by a quiet hand. The movement is unhurried, governed by changes in particle density and atmospheric layering. Sometimes the bands form braided patterns, curling into gentle twists before relaxing again. Other times, they appear as broad, slow-moving streaks that wander across the sky. This weaving of colors makes the aurora feel alive, responding to the planet's magnetic breath. And beyond these visible lights lies an even quieter display, invisible ultraviolet auroras glowing beyond sight, shaping the sky in wavelengths the eye cannot see. Invisible ultraviolet auroras glowing beyond sight occur when energetic particles excite gases in Earth's upper atmosphere, producing light in ultraviolet wavelengths. These auroras happen frequently, but because the human eye cannot detect ultraviolet, they remain hidden, except to specialized cameras or instruments aboard satellites. In UV, auroras often appear brighter and more structured, forming sharp arcs and detailed textures that echo the patterns seen in visible light. The science behind them is the same: oxygen and nitrogen releasing stored energy, but the wavelengths shift beyond our visual range. Even though unseen, these ultraviolet lights contribute to the overall glow of the night sky, adding subtle radiation that blends with airglow and starlight. They form a quiet, invisible layer above the visible aurora, moving with the same gentle rhythms and curving along magnetic paths. And as these silent wavelengths ripple through darkness, they prepare the stage for the next forms of night lights still to come. Auroral curtains drifting downward appear when charged particles funnel into Earth's magnetic field and collide with oxygen and nitrogen in the upper atmosphere, releasing photons that gather into long, flowing sheets of light. These curtains often seem to descend slowly toward the horizon, even though the movement is an illusion created by shifting particle density and changing field line geometry. The downward drift feels calm and deliberate, as if the sky is exhaling bands of color that fold gently into the night. Each sheet moves with subtle variations in brightness, flickering at the edges like fabric stirred by a quiet breeze. And as the curtains settle, the motion begins to shift into another form entirely: waves rippling in slow pulses that echo through the sky above them. Waves rippling and slow pulses form when bursts of charged particles arrive in rhythmic intervals, creating gentle undulations across the auroral bands. These waves stretch horizontally, rolling in long, smooth motions that travel across the sky like swells on a dark, silent ocean. Scientists have found that these pulses often match fluctuations in the solar wind, meaning the aurora can mirror distant conditions millions of kilometers away. To the eye, the ripples seem soft, almost sleepy, moving with a natural tempo that feels neither rushed nor forced. Colors rise and fall in brightness as if breathing, shifting from pale green to deeper hues as energy builds and fades. And as these waves drift outward and begin to twist, they climb into a new pattern spirals, climbing toward the stars, curling upward in elegant arcs. Spirals climbing toward the stars emerge when auroral structures follow magnetic field lines that bend sharply with altitude, causing light to twist upward in graceful, swirling forms. These spirals can appear tight and narrow, like coiled ribbons, or broad and loose, spreading into arcs that climb high into the atmosphere. The motion is guided by differences in particle velocity and subtle shifts in magnetic tension, creating patterns that look almost sculpted by the sky itself. Observers often describe the spirals as reaching upward, as though the aurora is stretching towards space with soft determination. Colors drift along the curves, glowing more strongly in the center and fading gently along the edges. And as these spirals unwind into longer strands, they begin to fall into vertical forms, rayed bands falling like soft rain through the night air. Rayed bands falling like soft rain appear when parallel beams of auroral light form along magnetic field lines, creating vertical streaks that shimmer downward in delicate patterns. Each ray is produced by a column of excited atmospheric atoms releasing light at slightly different times, making the whole structure flicker gently, like rainfall shaped from color. These rays often descend in coordinated waves, brightening and dimming as the incoming particle stream intensifies or fades. The vertical lines can stretch far across the sky, forming quiet curtains with fine, luminous threads. Because the bands align so closely with magnetic field geometry, they offer a glimpse of Earth's invisible structure made briefly visible. And as these rayed bands drift and reform, the sky sometimes opens into its most dramatic shape, corona auroras shooting upward in sudden, radiant bursts. Corona auroras shooting upward occur when perspective and magnetic alignment combine to make the lights appear to converge directly overhead, radiating outward like a great celestial fountain. These displays begin as multiple bands approaching the zenith, then suddenly flaring into a star-shaped pattern that seems to rise from a single point. Scientists note that the effect is partly geometric, created by the viewer standing beneath aligned field lines. But the brightness and speed of the motion give the corona an almost explosive grace. Colors spread outward in sharp rays that fade into soft edges, shifting from green to pink or violet as altitude changes. The upward burst feels both powerful and quiet, like watching energy bloom in total silence. And from this peak of movement, the aurora often softens again, spreading into calmer shapes for the next stage of the night sky's unfolding. Snake-like motions swaying gently appear when auroral bands become unstable along magnetic field lines, creating long, winding structures that move in slow, serpentine curves. These motions occur as charged particles shift unevenly through the upper atmosphere, causing the light to bend and weave like a ribbon stirred by an invisible hand. To observers on the ground, the swaying looks peaceful, almost hypnotic, as if the sky is breathing in long, even waves. The edges of the band blur and tighten, forming soft coils that stretch and relax in rhythm with distant solar conditions. Each motion is a reminder that auroras are alive with subtle dynamics rather than static displays. And as these snake-like forms continue drifting and softening, they begin to spread outward, transforming into broader shapes, diffuse aurora spreading thin glows that lace gently across the night. Diffuse aurora spreading thin glows appears when energetic particles enter the atmosphere in low densities, creating wide, faint sheets of light that feel more like a luminous haze than structured patterns. These glows often cover large portions of the sky with an even, mist-like brightness that seems to dissolve at the edges. Scientists note that diffuse auroras are connected to wave-particle interactions in the magnetosphere, causing particles to scatter and produce a softer, more uniform shine. To the eye, the effect is calming, like light gently seeping through a veil of darkness. The glow may flicker slightly as particle flow changes, but it never forms sharp outlines. As this faint light stretches outward, it can merge into larger, more defined arcs, auroral arcs, stretching across continents with quiet grandeur. Auroral arcs stretching across continents form when charged particles follow broad magnetic field lines, creating vast, sweeping bands of light that span thousands of kilometers. These arcs can reach from horizon to horizon, glowing steadily as they trace the natural curvature of Earth's magnetic field. Observers often describe them as bridges of soft color suspended across the night, held aloft by forces too distant and delicate to feel. The light within these arcs comes from stable particle precipitation, giving them a consistent glow that contrasts with the more dynamic forms around them. The arcs may hold steady for minutes, or slowly drift north or south as conditions change. And as these immense structures stabilize, they can break apart into smaller features, pulsating patches blinking softly in scattered patterns across the sky. Pulsating patches blinking softly develop when distant magnetospheric waves modulate the flow of energetic particles, causing isolated islands of auroral light to brighten and fade rhythmically. Each patch tends to pulse independently, glowing for a few seconds before dimming back into the darkness. The blinking is gentle and unhurried, like fireflies drifting through a vast, cold sky. These patches usually appear at higher altitudes, giving them a softer, more diffuse look than structured curtains or arcs. The pulses reveal the quiet interplay between particle energy and atmospheric gases, creating a natural heartbeat in the night. As these blinking clusters drift across the sky, they often signal the early stages of larger geomagnetic activity, substorms blooming into bright waves that sweep outward with expanding color. Substorms blooming into bright waves occur when energy stored in Earth's magnetotail is suddenly released, sending powerful bursts of particles toward the poles. This release transforms faint auroral structures into vibrant, expanding waves that brighten rapidly and spread across the sky. The blooming begins with a sudden intensification, often in a single spot, before unfolding outward like petals of color opening in silence. Though the process is energetic, the motion appears smooth and coordinated, flowing in glowing fronts that ripple with green, red, or violet hues. These waves can sweep across the entire auroral oval, creating some of the most dramatic and memorable displays. Yet even at their peak, they maintain a sense of natural harmony, an elegant reminder of how space and atmosphere interact. As the substorm fades, the sky gradually quiets again, settling back into softer forms for the next phase of the night's light. Auroras reflecting in calm lakes create one of the quietest forms of nightlight on Earth, where the sky and water mirror each other so perfectly that it becomes difficult to tell which side is the world and which side is the reflection. The still surface acts like a natural lens, stretching the green, red, or purple colors into long vertical bands that ripple only when the faintest breeze moves across the water. Scientists note that these reflections occur because the lake's surface becomes glass-like during stable, cold nights, allowing photons from the aurora to scatter evenly across the water. The effect feels like standing between two skies, one above your head and one beneath your feet. And as this mirrored light settles into the landscape, the glow often spills outward onto nearby snowfields. Snowfields glowing under shifting colors that drift silently across wide, frozen ground. Snowfields glowing under shifting colors turn the polar night into a soft panorama of brightness, where each snowflake acts like a tiny reflector, scattering the aurora's light in countless directions. Because snow has a naturally high albedo, it catches even faint auroral greens and reds, spreading them across the surface like watercolor pigments brushed over white paper. This creates the sensation that the ground itself is alive with movement, glowing gently in waves that correspond to the sky above. The snow muffles all sound, making the light feel even softer as it flows across open tundra. Scientists note that the snow's crystalline structure helps refract and diffuse the colors, softening the edges and blending hues into smooth gradients. And when the landscape brightens this way, the surrounding shapes begin to emerge more clearly. Mountains outlined by faint green light rising in quiet silhouettes. Mountains outlined by faint green light appear when auroral brightness reaches high enough to cast subtle illumination on rugged terrain. The peaks catch the glow first, their ridgelines forming delicate borders against the darker sky. To observers, the mountains seem both sharper and more distant at the same time, as if the aurora stretches space around them. The green tones occur when oxygen molecules high above the ground release photons after being excited by incoming particles. The emitted light washes over the landscape like a quiet brushstroke, giving solid stone a soft, almost weightless quality. The effect deepens as the aurora brightens, revealing cliffs, plateaus, and hidden snow pockets. And as this light trickles downward, it reaches the tree line, where forests flicker in polar calm, catching brief flashes of movement in their branches. Forests flickering in polar calm glow softly as auroral light filters through needles, branches, and snow-covered limbs. Each tree reflects or absorbs a slightly different shade, creating a mosaic of shifting color among trunks and shadows. The movement isn't fast or dramatic. Instead, the light passes through the canopy in slow, rhythmic pulses that match the aurora's drift overhead. Scientists describe this as diffuse reflection, where scattered photons bounce through the trees in ways that soften both color and contrast. The forest air is often still, allowing the faint green and violet hues to linger on bark, ice, and snow. Occasionally, a gust of wind will stir the branches, allowing the colors to shimmer briefly. And as these glowing woods quiet themselves again, the aurora often reaches outward toward the sea. Sea ice, glowing with soft reflections beneath the moving sky. Sea ice, glowing with soft reflections, occurs when broad sheets of frozen ocean act like textured mirrors, capturing auroral colors on their uneven surfaces. The cracks, ridges, and salt frost scatter the light in thousands of tiny directions, creating a gentle shimmer across the frozen landscape. Instead of a perfect reflection, the glow becomes a mosaic patches of pale green, hints of pink, or streaks of blue shifting with the slow motion of the aurora above. Scientists explain that sea ice reflects light differently than freshwater ice because of trapped brine pockets and surface crystals that alter the scattering patterns. To the observer, the effect is calm and dreamlike, as if the ice is quietly breathing in color. And as this glowing surface settles into the night, it naturally leads toward the next quiet scene, where auroras meet coastlines, cliffs, fields, and the wider sleeping world. Night silence, deepening in auroral glow, creates a kind of quiet that feels almost otherworldly, as if the entire landscape is listening. When the aurora brightens, it doesn't make sound, but instead seems to absorb noise, softening every movement beneath it. Snow dampens footsteps, distant winds become whispers, and even the smallest rustles fade. Researchers note that cold air layers tend to suppress sound, making nights under the aurora even more still than usual. In that stillness, the glow overhead feels more intense, spreading gently across the sky in slow-moving waves. The silence acts like a frame, making the light seem closer and more present. And as the quiet deepens, it reaches outward across the land, touching not only remote wilderness, but also the edges of human places. City lights dim beneath the sky's show, submitting to the aurora's calm brightness. City lights dim beneath the sky's show when auroras grow strong enough to outshine artificial glow, washing over streets, rooftops, and darkened fields with natural color. Even in small towns, the aurora's brightness can soften electric illumination, making street lamps seem faint and distant. Scientists explain that human-made light scatters downward, while auroral light descends from above, creating an unusual balance that makes urban environments appear gentler and quieter. Buildings cast softer shadows, windows reflect shifting green hues, and the sky feels larger, as if the edges of the city have blurred into the night. This blending of natural and artificial light creates a rare moment where human presence feels small against the calm of the atmosphere. And when the aurora brightens further, its light begins to move across the land, shaping gentle movements, soft shadows moving across open plains as the glow drifts overhead. Soft shadows moving across open plains appear when auroral waves sweep slowly from horizon to horizon, casting subtle gradients of brightness onto wide, level ground. The plains act like a canvas, receiving each faint shift in color and intensity. Because the light is diffuse and constantly changing, the shadows appear to drift, stretch, and fade, giving the land a quiet sense of motion. Atmospheric scientists note that these shifting shadows come from variations in auroral particle precipitation, which causes brightness to pulse across large regions. Grasslands, snowfields, and tundra respond differently, creating textures of darkness and light that move in delicate patterns. The effect is peaceful, like watching clouds pass across a sunlit field, but slower, quieter, and filled with soft color. And as the plains glow with these drifting forms, the distant edges of the world brighten polar horizons, shimmering like quiet fire. Polar horizons shimmering like quiet fire occur when strong auroral arcs sit low in the sky, glowing in colors that resemble flames but move with the softness of mist. Reds drift above greens, purples curl along the edges, and faint oranges appear when the particles reach specific altitudes. To observers far away, it looks like the edge of the Earth is lit from beneath by a silent, colorful burn. This illusion comes from photons released by oxygen and nitrogen molecules in the upper atmosphere, creating sheets of light that stretch across enormous distances. The horizon appears wider, almost curved, as if the planet itself is exhaling brightness. And as these fiery tones flicker gently along the edge of night, the glow often reaches downward, where the air grows colder and the ground sparkles ice crystals catching auroral rays in delicate, shimmering patterns. Ice crystals catching auroral rays create one of the most delicate interactions between light and the frozen world. Tiny hexagonal structures in snow, frost, or drifting ice suspend in the air and act like miniature prisms, scattering auroral colors into soft halos and glints. When the light hits them at just the right angle, they shimmer with pale greens or faint purples, as if the sky has left small fragments of itself on Earth. Scientists note that this scattering effect is similar to the way ice crystals create halos around the sun or moon, but auroral light gives the reflections a motion that mirrors the shifting sky. The crystals sparkle briefly before settling back into the cold, blending their glow into the surrounding landscape. And with that quiet shiver of light, the scene becomes whole, a frozen world gently illuminated by the moving colors above. Auroral ovals circling the poles appear as continuous rings of light when viewed from space, forming gentle halos that wrap around Earth like glowing boundaries between night and the upper atmosphere. These ovals mark the regions where charged particles most often enter the atmosphere, guided by the planet's magnetic field. From orbit, they look steady and structured, far more constant than the shifting curtains seen from the ground. The green or red light spreads in smooth arcs, brightening and dimming as solar wind conditions change. The ovals expand during geomagnetic storms and contract when space weather settles, creating a quiet pulse pattern around the planet. And as these luminous rings flow around both hemispheres, the light begins to curve along the edge of the world, Earth's limb glowing in calm arcs that rise softly against the darkness of space. Earth's limb glowing in calm arcs happens when auroral light hugs the curve of the atmosphere, creating a soft, thin band of color that outlines the planet's edge. From orbit, this glow appears delicate and precise, like a brushstroke painted along the horizon. Scientists note that this limb brightening occurs because the line of sight passes through a long slice of glowing atmosphere, intensifying the brightness. The result is a gentle ribbon of green or red that separates Earth from the surrounding darkness. This boundary seems to breathe, thickening slightly during stronger auroral activity, and fading when particle flow decreases. The calm arc turns the planet into a softly lit sphere floating in quiet space. And as this curve brightens, it reveals more structure above satellite views of drifting green rings that shift gradually around the poles. Satellite views of drifting green rings show the aurora as large-scale patterns spreading smoothly across the night side of Earth. From hundreds of kilometers above, satellites detect variations in brightness that the human eye can't easily see from the ground. The rings drift subtly as the magnetic field guides particle flows, forming patterns that look like slow tides of light moving around the poles. Instruments aboard satellites capture both visible color and ultraviolet emissions, revealing layers of auroral activity stacked like translucent sheets. The view is serene, wide arcs, faint spirals, and soft patches expanding quietly across the atmosphere. These global patterns remind scientists that auroras are not just local displays, but planetary-scale interactions shaped by solar wind. And as the satellites watch these gentle movements unfold, a more personal vantage point emerges nearby the ISS, astronauts watching soft nightglow from their windows. ISS astronauts watching soft nightglow often describe the experience as one of the most peaceful sights in orbit. From the station's vantage point, moving at over 27,000 kilometers per hour, the aurora sweeps beneath them like a living river of color. The green bands appear thick, almost three-dimensional, rising from the atmosphere in slow curls that fade upward into darkness. The station passes above, and sometimes even through the uppermost edges of the aurora, surrounding astronauts with drifting light. Scientists note that this proximity allows unique observations of particle interactions and atmospheric composition. But beyond science, the view is simply calming Earth, glowing quietly below, space stretching silently above. And as the ISS glides along its orbit, the aurora often aligns perfectly with the planet's edge auroras, framing Earth's horizon in a gentle, luminous arc. Auroras framing Earth's horizon form when strong auroral activity stretches far enough upward to outline the curve of the planet with drifting color. The horizon becomes a glowing rim, where the atmosphere lifts into thin layers of green, red, or violet. Seen from space, this light forms a soft halo, blending slowly into the darkness above. The effect comes from light-emitting particles distributed at different altitudes, creating height variations in the auroral glow. The silhouette of the Earth beneath provides a quiet contrast, deepening the sense of scale and calm. As spacecraft pass along the curve, the glowing edge shifts, following the planet's rotation and the movement of magnetic field lines. It feels like watching a gentle sunrise, made of particles instead of light. And as this horizon halo fades slowly into orbital night, the aurora continues its journey around the poles, waiting to be seen again from above or below. Thin, atmospheric layers lighting up become visible from space when auroral energy spreads through distinct altitudes, causing narrow sheets of air to glow like stacked veils. These layers aren't usually seen from the ground, but from orbit they appear as horizontal bands, greens near 100 kilometers, reds higher above, and faint purples at the edges. Scientists explain that each altitude responds differently to incoming particles, creating a layered structure that resembles a softly illuminated staircase between Earth and space. The light seems to hover in place even as the planet turns underneath, offering a quiet view of the atmosphere's inner architecture. And as these layers brighten in gentle succession, the glow often extends outward across the planets. Dark side lights blooming above dark oceans in wide, moving arcs. Lights blooming above dark oceans occur when auroras stretch over open water, forming expansive glows that illuminate the sea surface far below. Without city lights or terrain to interrupt the view, the auroral bloom looks even larger and smoother, spreading across thousands of kilometers with gentle transitions. From orbit, astronauts often see these blooms before they see any outline of land, appearing like soft lanterns floating on the edge of night. The ocean reflects only a faint trace, making the light seem suspended between sky and sea. Scientists note that strong solar wind conditions can generate these wide blooms, covering vast ocean basins with subtle green or red tones. And as these blooms flicker and move, they become measurable patterns for instruments, spaceborne sensors catching gentle pulses in the glow. Spaceborne sensors catching gentle pulses detect fluctuations in auroral brightness that are too subtle for the human eye. These pulses occur when waves in the magnetosphere modulate the flow of charged particles, creating rhythmic variations in luminosity. Sensitive detectors aboard satellites pick up these shifts, mapping the aurora's heartbeat as it spreads across the atmosphere. To scientists, these measurements reveal the timing and structure of solar-Earth interactions. To observers, the idea of a pulsing sky adds another layer of quiet elegance to the aurora's presence. The pulses appear as soft, brightening and dimming patterns drifting across the night side of Earth, and as satellites track these gentle rhythms, they often capture another sight unfolding below Aurora, drifting around Earth's curve in long, serene bands. Aurora drifting around Earth's curve appears from orbit as smooth arcs sliding across the rounded horizon, forming luminous pathways that follow magnetic field lines. These drifting bands move slowly, matching the planet's rotation and the flow of charged particles. From space, the curvature of Earth makes the aurora look like a glowing belt, bending gracefully around the poles. The movement is steady and unhurried, showing how large-scale the auroral system truly is. Scientists analyzing these drifts use them to understand changes in the magnetosphere and solar wind. But visually, the effect is simple and calm, light tracing the shape of the planet in a soft sweep. And as these drifting arcs expand or contract, they begin to meet at the edges, forming a wider pattern, polar lights merging into global halos. Polar lights merging into global halos occurs during strong geomagnetic activity, when auroral arcs extend far enough to form a nearly continuous ring of light around the planet. From orbit, this halo appears as a luminous crown encircling Earth, glowing in a mixture of green, red, and violet hues. The effect is created by large-scale particle precipitation covering both polar regions simultaneously. The halo moves gently, thickening or thinning with solar wind pressure. Scientists see this as a sign of coordinated magnetospheric dynamics, while astronauts describe it as one of the most serene sights in space. Earth, wearing a soft, shifting ring of color. As the halo stabilizes, it becomes a reminder that the aurora is not just a local phenomenon, but a global one, uniting both hemispheres in one calm, luminous motion. Green night glow shining in upper air forms when oxygen atoms high in the mesosphere release stored energy collected during the day, creating a faint, widespread green luminance that blankets the night sky. Unlike auroras, which burst with motion, night glow is steady and delicate, appearing even during calm solar conditions. Scientists describe it as a quiet breathing of the atmosphere, a constant emission that helps balance energy between day and night. To the eye, the glow is invisible or barely perceptible, except under the darkest skies. Yet from space, it appears as a soft field of color stretching from horizon to horizon. The green shade comes from oxygen radiating at a specific wavelength, giving the night a gentle radiance that sits far above weather. And as this subtle layer settles over the sleeping world, it mingles with other colors forming higher above red, night glow drifting above storms in even quieter tones. Red night glow drifting above storms originates from excited oxygen atoms far higher than the green layer, creating a soft reddish emission that spreads lightly across the upper atmosphere. This red glow becomes visible from orbit as a thin, luminous band floating above the dark planet, shifting gently as atmospheric waves ripple through the air. Scientists note that strong thunderstorms below can influence these waves, sending upward pulses that bend and shape the night glow. But despite these connections, the glow remains steady and silent, unaffected by the noise of the weather beneath it. From remote mountaintops or deserts, Sensitive cameras can capture this red luminescence, stretching across the sky like a faint watercolor wash. And as the red layer wavers, it gradually blends downward into cooler tones, blue night glow forming below in calm, diffuse fields. Blue night glow forming below appears in lower atmospheric layers where molecular oxygen interacts with incoming energy, producing a faint bluish emission. This color is much harder to detect than green or red night glow, but becomes visible in long exposure images as a soft, gentle haze resting above the horizon. Scientists associate this phenomenon with photochemical reactions initiated by sunlight that continue long after day fades. In clear, dry air, the blue glow seems to float like a thin mist suspended in the darkness, shifting slowly with atmospheric tides. Its presence indicates ongoing energy exchanges between different air layers, revealing how the atmosphere never fully sleeps. As this blue radiance rises and falls, it forms part of the broader tapestry of night luminescence ozone, creating faint chemical light in another quiet layer above it. Ozone, creating faint chemical light, occurs through chemiluminescence, when ozone molecules react with atomic oxygen and release small amounts of energy as gentle luminosity. This subtle glow is usually invisible to human eyes, but contributes to the overall brightness of clear night skies. Scientists identify this ozone emission as a key component of airglow, forming thin, rippling bands that follow atmospheric waves. To remote sensors and specialized cameras, the ozone light appears as smooth streaks stretching across the sky, moving slowly with shifts in pressure and temperature. The glow helps trace the hidden motions of the upper atmosphere, revealing patterns that resemble soft, drifting rivers of color. And as these quiet chemical reactions continue hour after hour, they light up yet another layer, sodium layers glowing gently at the edge of space. Sodium layers glowing gently occur when sodium atoms released by meteors accumulate around 90 kilometers above Earth, forming a thin, shimmering sheet that responds to atmospheric movement. When excited by sunlight during the day, these atoms store energy and release it at night as a soft golden glow. From the ground, this sodium emission is usually invisible, but sensitive instruments detect it as a warm, delicate band stretching across the night sky. Scientists use this layer to study atmospheric gravity waves, which cause the glow to ripple like a slowly moving tide. The sodium layer acts almost like a natural backlight, responding subtly to every shift in temperature and density. And as this warm glow drifts across the upper atmosphere, it leads naturally into deeper, broader forms of night luminescence waiting higher above. Air molecules releasing stored sunlight create one of the softest sources of natural night brightness. During the day, gases like oxygen and nitrogen absorb solar energy, holding it quietly until darkness falls. When night arrives, these molecules release that stored energy as faint luminescence, producing part of what we call airglow. This emission is extremely gentle, far dimmer than moonlight, but sensitive cameras reveal it as thin, glowing veils across the sky. Scientists see it as the atmosphere's way of balancing daytime energy, letting it fade slowly rather than all at once. The light forms narrow layers that shift with atmospheric waves, creating patterns that resemble ripples moving through invisible water. And as these soft emissions drift across the sky, they begin organizing themselves into broader structures, night glow rippling in thin sheets that glide across the darkness with almost dreamlike calm. Night glow rippling in thin sheets occurs when atmospheric gravity waves travel upward from storms, mountains, or temperature boundaries, causing the glowing layers to bend and move. These ripples can stretch across hundreds of kilometers, creating smooth, wave-like stripes that slide through the upper atmosphere. To the naked eye, the effect is usually too faint to notice, but long exposure images reveal beautiful, undulating bands that seem to drift like soft curtains. Scientists use these ripples to trace the behavior of air layers that would otherwise be invisible. Watching how the glow bends, rises, and settles, the motion is unhurried, creating a peaceful sense that the entire sky is breathing. And as these glowing sheets shift across the heavens, they merge with other faint emissions, upper atmosphere, humming with color as more molecules join the slow radiance. Upper atmosphere humming with color describes the collective effect of many faint emissions: green from oxygen, red from oxygen higher up, blue from molecular reactions, and golden from sodium atoms. Together, they create a gentle tapestry of light that fills the air above 80 kilometers. Though this hum is visual rather than audible, the steady glow suggests a quiet vibration, a natural resonance of the planet's outer skin. Scientists study these colors to understand energy flow, but to the imagination, the combined glow feels like a soft aura surrounding Earth. The layers overlap and shift as atmospheric tides rise and fall, blending into a calm, multidimensional brightness. And as this quiet radiance spreads across the night, it softens the edge between space and sky stars, blending into glowing haze where the upper atmosphere meets the cosmos. Stars blending into glowing haze happens when faint airglow layers overlap the starlight, giving the sky a slightly luminous background that softens the contrast between bright points and dark space. Instead of sitting against a stark black canvas, the stars appear to float within a gentle wash of diffuse color. In very dark locations, the haze becomes visible as a soft green or red brightness stretching along the horizon. And as this quiet radiance spreads across the night, it softens the edge between space and sky stars, blending into glowing haze where the upper atmosphere meets the cosmos. Stars blending into glowing haze happens when faint airglow layers overlap the starlight, giving the sky a slightly luminous background that softens the contrast between bright points and dark space. Instead of sitting against a stark black canvas, the stars appear to float within a gentle wash of diffuse color. In very dark locations, the haze becomes visible as a soft green or red brightness stretching along the horizon. This global emission comes from multiple chemical processes, happening simultaneously across different atmospheric layers, creating a single, coordinated radiance. From space, the night glow reveals the structure of Earth's atmosphere: waves, bulges, dips, and long horizontal streaks shaped by winds and temperature differences. Scientists use this planetary glow to study circulation patterns and energy transport on a global scale. Yet, from a human perspective, the sight carries a deep sense of calm. Earth, surrounded by a quiet, living light, breathing softly into space. Moonlight scattering into soft silver happens when sunlight reflected from the lunar surface interacts with Earth's atmosphere, spreading into a gentle glow that brightens the night without overwhelming it. The moon's light is already muted compared to daylight, and when it passes through layers of air, faint particles scatter it into a soft radiance that feels peaceful and steady. Scientists explain that this scattering is similar to the process that turns daytime skies blue, but at night it creates a pale, silky illumination that rests lightly across landscapes. Snow reflects it with surprising brightness, water mirrors it in trembling ribbons, and forests catch only the thinnest threads of silver. As the moon rises and sets, this scattered light shifts quietly across the world, guiding nocturnal movement and calming the night. And as the moonlight softens everything it touches, other atmospheric wonders begin to appear: lunar halos circling quietly around the moon's glowing crown. Lunar halos circling quietly arise when moonlight passes through high, icy cirrus clouds, where hexagonal ice crystals refract the light into a glowing ring. The halo often measures 22 degrees across, forming a soft, pale circle that seems to hover around the moon like a misty frame. These halos form silently, revealing the presence of ice crystals far above the ground long before weather patterns shift. Scientists note that each tiny crystal acts as a prism, bending the moonlight at precise angles to create the ring. To observers, the halo appears gentle and otherworldly, a calm reminder of the structures floating in the upper sky. The light blends seamlessly into the night, bright enough to see, yet faint enough to feel like a whisper. And as the halo settles into the quiet sky, Its light sometimes stretches downward moon pillars, rising in still air, as reflections stack softly beneath the moon. Moon pillars rising in still air form when moonlight reflects off flat, plate-like ice crystals drifting slowly through cold, stable layers of atmosphere. These reflections stretch vertically, creating a narrow column of soft light that appears to rise between the moon and the horizon. The pillar flickers gently as the crystals shift orientation, producing a calm, shimmering effect. Scientists explain that this phenomenon is similar to sun pillars, but the moon's lower brightness gives the pillar a more delicate, subdued appearance. It often appears during quiet winter nights when the air is cold, dry, and motionless. The pillar serves as a silent signal of the crystals floating in the sky, tracing their presence with silver light. And while the pillar sways gently, the stillness of the night invites another quiet phenomenon to cross the sky. Meteors streaming with quiet sparks that vanish almost as soon as they appear. Meteors streaming with quiet sparks occur when tiny cosmic particles enter Earth's atmosphere at tremendous speed, heating the air around them and producing brief streaks of light. Despite their fiery appearance, meteors make no sound for observers on the ground. The burn happens dozens of kilometers above, where air is too thin to carry noise. The streaks appear suddenly, flash softly, and fade into darkness, leaving the sky even quieter than before. Scientists note that most meteors are no larger than grains of sand, yet they paint delicate arcs across the night as they disintegrate. On calm nights, dozens may appear in a single hour. And when the meteor trails fade, they leave behind faint dust illuminated by the sun below the horizon, zodiacal light, glowing before dawn in a soft, triangular haze. Zodiacal light, glowing before dawn, emerges when sunlight scatters off interplanetary dust that fills the inner solar system. This dust forms a broad, gentle column of brightness along the ecliptic, appearing as a pale, triangular glow rising from the horizon. The light is easiest to see in very dark, clear conditions, where artificial brightness doesn't overpower its subtle shimmer. Scientists explain that the dust originates from comets and asteroid collisions, creating a delicate cloud that reflects sunlight long before the sun itself appears. To the observer, zodiacal light feels like the first hint of morning, even though the world remains in deep night. Its glow grows slowly, then fades as the sky brightens, and as it blends into dawn, it reveals the quiet structure of space itself, a reminder that even in darkness, faint light is always moving around us. Gegenschein, forming in deep darkness, appears as a faint oval glow directly opposite the sun in the night sky, visible only where artificial light is absent and the air is exceptionally clear. This delicate brightness comes from sunlight, reflecting off interplanetary dust particles, positioned at just the right angle to concentrate the scattered light. Scientists describe it as one of the most subtle optical features visible to the human eye, requiring patience and stillness to perceive. When it emerges, it feels like a soft echo of daylight, lingering quietly in space, suspended above the horizon in a pale, ghost-like sheen. The glow does not flicker or move. Instead, it hangs steadily, deepening the sense of night's vast reach. And once your eyes adjust to this fragile brightness, the rest of the sky begins to sharpen around it. Starlight, twinkling through calm air, like tiny signals sent across unimaginable distances. Starlight twinkling through calm air reveals the atmosphere's gentle imperfections, each tiny shimmer caused by subtle pockets of warm and cool air bending the incoming light. The stars themselves remain steady, but the shifting air creates the illusion of flickering, giving the sky a soft, living quality. Scientists call this scintillation, and while it can disrupt telescopic observations, it adds beauty to the naked eye sky. On quiet nights, the twinkling becomes slower and more delicate, as cooler, stable layers settle across the landscape. The result is a field of tiny, trembling lights that appear to breathe with the night. Some stars flash hints of color, blue, red, or white, adding texture to the darkness. And as the twinkle deepens the sense of stillness above, the sky reveals its larger structure, Milky Way, drifting across silent skies in a broad river of faint light. Milky Way drifting across silent skies appears as a soft, luminous band stretching from horizon to horizon, made of billions of distant stars whose combined glow forms a gentle wash of brightness. In very dark places, this galactic ribbon becomes detailed enough to show dust lanes and subtle gradients, like watercolor strokes painted across space. Scientists note that its appearance changes with the seasons, rising and setting in slow arcs that echo Earth's motion around the Sun. To the viewer, the Milky Way offers a sense of scale that is both humbling and peaceful, reminding us of the quiet expanse beyond our planet. Its presence anchors the night, creating a backdrop for every smaller glow and flicker. And as the galaxy's soft band brightens the sky, it contrasts with signs of human presence far below light, domes from distant towns, spreading faintly at the edges of the horizon. Light domes from distant towns form when artificial light scatters upward and reflects off airborne particles, creating a gentle glow that rises like a rounded hill above the horizon. Even far from cities, this scattered illumination can appear as a soft orange or white haze, blending gradually into the natural sky. Scientists study this phenomenon to understand light pollution and its effects on wildlife, astronomy, and human perception. Despite its artificial origin, the dome can appear strangely calm when seen from remote landscapes, standing quietly beneath the stars. The glow shifts subtly with humidity, cloud cover, and atmospheric clarity, sometimes brightening after rain or dimming during cold, dry nights. And while these domes remind us of distant human activity, they also create a contrast that highlights the purity of natural darkness above faint lightning, illuminating high clouds in quiet, momentary flashes. Faint lightning illuminating high clouds occurs during distant storms, when flashes inside towering cumulonimbus clouds glow softly across the sky without producing thunder where you stand. These silent bursts, known as heat lightning, travel great distances, their light diffusing through layers of air and cloud. The illumination reveals the outlines of massive cloud structures, anvil tops, rising pillars, and trailing wisps painting them briefly against the night. Scientists explain that the lightning itself is not silent. The sound simply cannot reach across such distances due to atmospheric absorption and curvature of the Earth. To the observer, the flashes appear gentle and detached, like quiet breaths of energy far away. Each faint pulse glows for a moment, then fades into darkness, leaving the sky even more peaceful. And as these distant lights flicker softly, the night prepares to reveal its deeper and more ancient rhythms. Polar night, deepening into stillness, begins when the sun slips below the horizon for weeks or months at a time, leaving the Arctic and Antarctic wrapped in a gentle, persistent twilight. Instead of complete darkness, the sky holds a faint, lingering glow, blue at midday, deep violet at night, created by scattered sunlight traveling long distances through the atmosphere. Scientists note that this extended darkness changes the behavior of winds and temperature layers, producing some of the calmest air on Earth. Sound travels differently too, becoming muted as snow absorbs every footstep and distant movement. To those who witness it, the polar night feels less like absence and more like a soft, unbroken pause in time. And as the stillness settles into the landscape, the sky slowly prepares for its winter lights. Long winter skies opening for auroras that drift across the darkness in patient, glowing arcs. Long winter skies opening for auroras create a sense of endless space, as if the darkness itself has made room for light to move freely. With the sun far below the horizon, even faint auroras become vivid, spreading in smooth bands across the star-filled sky. Scientists explain that long polar nights allow more energetic particles to reach the atmosphere without interference from sunlight, strengthening these winter displays. The cold, stable air keeps the sky unusually clear, sharpening every ripple of color. The world beneath grows quiet as snow muffles sound and ice reduces movement, heightening the contrast between darkness and drifting light. The auroras rise and fall in slow breathing patterns, reflecting the larger rhythms of space weather far beyond Earth. And as these lights glide across the frozen world, they reveal delicate features on the ground, frost crystals glowing under moonlight like tiny mirrors of the sky. Frost crystals glowing under moonlight turn the frozen surface of the polar regions into a soft field of light, where each tiny crystal catches and scatters pale illumination. These crystals form when humid air meets intense cold, creating intricate, hexagonal shapes that grow in silence across snow, ice, and exposed rock. Scientists note that frost has a high reflectivity, allowing even faint moonlight to create shimmering patterns that shift as the viewer moves. In calm weather, the glow appears almost motionless, like a thin layer of starlight collected on the ground. The crystals sparkle gently when disturbed by the wind, creating brief flickers that resemble distant fireflies trapped in ice. And as the frosted landscape brightens, the light begins to extend outward, merging ground and sky ice sheets, reflecting sky colors in smooth, blended tones. Ice sheets reflecting sky colors create vast, luminous surfaces that mirror the shifting tones above deep blues during twilight, pale greens beneath auroras, and silver under moonlight. These massive expanses of ice act like natural mirrors, scattering light across ridges, cracks, and frozen plains. Scientists note that the optical properties of glacial ice vary with age, density, and trapped air, producing subtle variations in reflection that reshape the landscape with every change in the sky. When auroral light falls across an ice sheet, it can stretch the glow for kilometers, creating the illusion that the ground itself is shining. This quiet interplay between sky and surface softens the starkness of the polar world, turning it into a gentle, blended palette of color. And as these mirrored planes extend into the distance, they frame the edges of the horizon, quiet horizons, stretching into darkness in endless, peaceful lines. Quiet horizons stretching into darkness define the edges of the polar night, where land, ice, and sky blend into a single, serene gradient. These horizons appear unusually smooth because cold, stable air prevents shimmering and distortion, allowing the boundary between Earth and atmosphere to appear sharp yet gentle. Scientists note that during long polar nights, the lack of sunlight reduces atmospheric turbulence, creating some of the clearest horizon lines on the planet. The darkness feels soft rather than heavy, opening into an expanse that seems to go on forever. Occasional distant lights, faint auroras, moonlit clouds, or reflections on snow add quiet variation without breaking the calm. Standing before such a horizon feels like looking into deep, unbroken stillness, where time seems to slow and the world rests beneath its longest night. And from this still horizon, the sky prepares for the next quiet transformation, waiting deeper in the poles. Stars sharpening in frozen air happens because cold, stable layers near the surface reduce atmospheric turbulence, allowing starlight to pass through with far fewer distortions. In the polar night, temperature inversions often form cold, dense air sitting close to the ground, with warmer layers above creating some of the clearest astronomical conditions on Earth. Scientists note that when the air is this stable, the usual shimmering of stars nearly disappears, making them appear steady, crisp, and unusually bright. The frozen landscape below reflects little light, deepening the darkness until the stars seem pressed closer to the Earth. Their clarity adds a quiet intensity to the night, turning the sky into a sharp, glittering dome. And as these steady points of light shine above the snow, they become the backdrop for another nightly ritual aurora, forming nightly arcs that drift across the dark with slow, patient grace. Aurora forming nightly arcs unfolds as charged particles follow magnetic field lines into the atmosphere, creating soft ribbons of green, red, or violet that appear again and again during long polar winters. These arcs often stretch across the entire sky, forming gentle curves that mirror Earth's magnetic geometry. Scientists observe that during extended darkness, the atmosphere cools deeply, increasing clarity and allowing even faint arcs to be seen with ease. To the observer, these recurring lights feel almost ceremonial, appearing quietly, moving slowly, repeating their presence night after night. The arcs may brighten in places or split into thinner strands, but their overall shape remains calm and steady. And as these luminous forms drift across the frozen world, they subtly color the air around them. Calm winds carrying faint color through still winter layers. Calm winds carrying faint color occur when gentle atmospheric motion disperses the aurora's light just enough to tint thin clouds, ice crystals, or drifting snow. In the polar night, winds often move in slow, broad patterns, shaped by stable pressure systems and intense cold. These soft currents blend the edges of auroral arcs, spreading their glow across the horizon like watercolor pigment pulled lightly by a brush. Scientists describe how fine ice particles in the air scatter this colored light, creating halos, veils, and subtle gradients that hover above the land. The winds themselves are barely felt, but their influence appears in the delicate smearing of brightness across the sky. And as these colored breezes pass over the ocean, they illuminate another quiet surface ocean ice, glowing with night lights beneath the drifting sky. Ocean ice, glowing with night lights, happens when auroral colors reflect across frozen seas, catching ridges, cracks, and frost-covered surfaces. The reflection is not mirror-like, but scattered, turning the ice into a patchwork of soft greens and faint purples. Scientists note that sea ice contains pockets of air, salt, and layered crystals, all of which alter the way light spreads through it, producing uneven but beautifully blended glows. In some conditions, bioluminescent organisms beneath thin ice also contribute tiny bursts of light, further softening the scene. The ocean remains silent beneath the frozen cover, creating a stillness that amplifies every color above it. And as the glowing ice stretches across the horizon, the polar night settles around it in deep, quiet darkness, holding soft motion as light continues to shift, ripple, and breathe. Darkness holding soft motion defines the final character of polar night, a darkness that is never empty, but filled with slow, rhythmic changes. Even without the sun, the atmosphere moves in gentle waves, auroras drift in patient arcs, and distant stars wheel quietly overhead. Scientists explain that gravity waves, thermal tides, and magnetic activity continue shaping the sky throughout the long night, creating subtle motion that never disturbs the overall calm. To anyone standing on the ice, the darkness feels protective rather than heavy, as if the world has chosen to rest without becoming still. Light shifts lightly across snow, shadows breathe with auroral pulses, and the horizon remains a soft boundary between earth and sky. Within this deep quiet, every movement is unhurried, reminding the viewer that the polar night is not void but a slow, peaceful world unto itself. Light drifting across Earth's magnetic field becomes one of the most delicate motions in the night sky, shaped not by wind or weather but by invisible lines of force stretching outward from the planet. Charged particles follow these lines in soft, curving paths, releasing faint light as they descend into the upper atmosphere. Scientists often describe this movement as a graceful flow, almost like a river of light bending around Earth. From the ground, it appears as the first hints of aurora, thin, wandering glows that stir the darkness without breaking it. From space, the light traces enormous loops that wrap the planet in gentle arcs. And as these luminous threads drift around Earth, they add to a much broader brightness, night glow, keeping the planet softly lit, even when no aurora is present. Night glow, keeping the planet softly lit, emerges from constant chemical reactions in the mesosphere and thermosphere, where oxygen, nitrogen, and trace gases release energy long after sunlight fades. This glow is faint, but steady, forming thin layers that ripple quietly with atmospheric waves. Scientists note that without night glow, the night side of Earth would be significantly darker, lacking the subtle illumination that softens horizons and silhouettes. The glow shifts gently in brightness, responding to tides of temperature and pressure that move through the upper air like slow, invisible breaths. And while auroras dance and flare, night glow remains patient and unmoving, a constant canvas upon which brighter lights appear. As this soft radiance spreads around the planet each night, it becomes the background rhythm for more dramatic displays, auroras moving like slow breathing across the darkness. Auroras, moving like slow breathing, reveal the gentle side of geomagnetic energy, expanding and contracting in glowing waves that resemble the rise and fall of a sleeping world. Though driven by powerful solar particles, their motion often appears calm, unhurried, and deeply rhythmic. Scientists studying magnetospheric dynamics describe this pulsing as a natural cycle, almost like the atmosphere's heartbeat. Greens brighten and fade, reds stretch and soften, purples curl along the edges in slow arcs. The lights gather, expand, then drift apart, each movement blending smoothly into the next. The effect invites stillness, as if the sky is inhaling and exhaling light. And as these colors drift gently across the poles, they share the sky with another faint presence, space dust, reflecting calm starlight in quiet, scattered glimmers. Space dust reflecting calm starlight appears in the form of soft glows and faint brightening along the ecliptic, where countless microscopic particles drift through the inner solar system. Each grain reflects just a tiny fraction of incoming starlight, but together they create a subtle shimmer that fills the darkness with quiet texture. Scientists explain that these dust particles come from comets, asteroid collisions, and ancient material left over from planetary formation. To the naked eye, their reflected light is barely visible, seen as faint arcs or soft hazes before dawn or after dusk. Yet, this dust is always present, absorbing and releasing starlight with gentle patience. As its glow spreads thinly across the sky, and from this soft scattering, the night deepens into its quietest state, darkness, revealing hidden colors that appear only when the sky is still. Darkness, revealing hidden colors, happens when the night reaches its deepest clarity, allowing the faintest wavelengths to emerge from stars, air glow, and distant nebulae. In true darkness, the sky is not black, but layered with subtle blues, greens, and reds, shaped by scattered starlight and atmospheric emissions. Scientists studying low-light vision note that rods in the human eye become sensitive enough to detect these variations, turning the sky into a gentle gradient rather than a void. Under polar nights or desert skies, the Milky Way shows warm dust tones, while airglow paints quiet green bands near the horizon. Even shadows take on color blue under moonlight, gray under starlight, and pale green when auroras drift nearby. And as the night reveals these hidden hues, the sky prepares to offer its final, most peaceful forms of light. The sky, holding ancient solar memory, becomes clear when you recognize that every faint glow, every soft band of color, carries traces of sunlight absorbed earlier in the day or even stored across seasons. Air molecules keep tiny packets of solar energy, releasing them slowly as night glow. Dust grains reflect starlight shaped by sunlight, billions of years old. Auroral particles originate from solar wind that left the sun days before, arriving only after drifting quietly across millions of kilometers. Scientists describe the upper atmosphere as a reservoir of past light, constantly exchanging energy in delicate chemical reactions. This retained brightness creates a sky that never fully darkens, glowing with echoes rather than direct illumination. And as these ancient traces drift through the air, they begin to align with larger celestial patterns, night lights tracing cosmic rhythms that move far beyond Earth itself. Night lights tracing cosmic rhythms occurs as auroras, night glow, meteor trails, and zodiacal light all respond to cycles shaped by Earth's rotation, the magnetosphere's breathing patterns, and tides of solar wind. These rhythms repeat at scales ranging from minutes to months to decades, forming an intricate choreography of natural light. Scientists map these cycles using satellite data and ground-based instruments, finding patterns that resemble slow heartbeats or gentle waves traveling across the sky. To the eye, the lights seem to follow invisible cues, brightening and dimming in harmony with forces far above the atmosphere. The night becomes a canvas where cosmic timing reveals itself in soft glows and drifting colors. And as these rhythms continue, they fade into an even larger motion, the universe shimmering in quiet motion all around the planet. The universe shimmering in quiet motion becomes visible when deep darkness allows starlight, nebulae, and distant galaxies to emerge with clarity. Even without powerful telescopes, the night sky reveals subtle flickers, stellar scintillation, faint hues in the Milky Way, and soft gradients shaped by cosmic dust. Scientists explain that galaxies move, stars pulse, and interstellar clouds drift, yet these vast motions appear peaceful from Earth due to their immense distance and timescales. The result is a sky that seems perfectly still, while actually filled with continuous, gentle change. Long exposures reveal the shimmer more clearly, tiny specks shifting softness across the darkness. And as this quiet, cosmic texture surrounds the world, Earth becomes part of that glow. Earth glowing softly beneath the stars as its own lights rise into the night. Earth glowing softly beneath the stars happens through a blend of auroral arcs, night glow bands, reflected moonlight, and scattered starlight. Seen from space, these combined lights trace coastlines, ice sheets, mountain ranges, and vast stretches of ocean with delicate brightness. Even uninhabited regions shimmer faintly under atmospheric luminescence. Scientists studying Earth's night side describe it as a softly illuminated sphere, wrapped in thin layers of photochemical glow that shift with temperature and magnetic conditions. From the ground, this softness appears as pale halos near the horizon or faint glimmers rising from the snow. Earth becomes both viewer and participant in the night sky, exchanging light with the cosmos. And as this glow settles into its quietest form, the night reaches its final expression, night itself resting in gentle radiance. Night itself resting in gentle radiance emerges when all sources of natural light, auroras, stars, airglow, reflected moonlight, and cosmic dust blend into one calm, continuous brightness. The darkness is never empty. It holds soft gradients, subtle motion, and ancient light drifting from countless origins. Scientists describe this radiance as the background state of the night atmosphere, shaped by chemistry, magnetism, and cosmic energy. To the observer, it feels like a peaceful presence, steady and unhurried, filling the sky with a quiet invitation to rest. The night seems to breathe, not in flashes or bursts, but in slow transitions of color and brightness. And within this resting radiance, the world feels suspended between day and tomorrow, a final reminder that even in darkness, light persists in the softest possible forms. Thank you for spending this quiet time here. You made space for yourself, and that already matters more than you think. For a little while, you let the world slow down. You allowed the sky to unfold above you, not with drama or urgency, but with the gentle movements that only appear when the night is calm enough to notice them. All the soft radiance we explored tonight was already there, drifting above forests, oceans, snowfields, and sleeping cities. You simply gave yourself permission to look up, breathe, and let the darkness soften. Maybe you arrived here feeling heavy or overstimulated, carrying more than you meant to. Or maybe you simply wanted a place where your mind could loosen its grip on the day. Either way, you reached the end of this journey, and I hope the night sky offered you the quiet you were seeking. Not silence in the sense of emptiness, but silence that feels full, steady, and safe. A silence shaped by starlight, by auroras breathing across the poles, by the patient glow of night air holding traces of the sun. The sky is often thought of as vast and unreachable, but tonight we approached it gently, through its softest forms, the green glow drifting in the upper atmosphere, the slow arcs of auroras shaping themselves like breaths, the delicate shimmer of dust reflecting starlight, even the shadows and the darkness themselves settling into calm gradients, reminding us that not every part of life demands brightness. Some parts only need to be felt and then held quietly. As you listen to these 100 small stories, the night may have changed around you too. Maybe your room dimmed, maybe the air cooled, maybe your heartbeat slowed without you noticing. Night has a way of drawing attention inward, then outward, then dissolving the boundary between both. And the lights we explored are part of that rhythm. They are reminders that even the darkness contains motion and color, that rest is not an absence of energy, but a different form of it. If your eyes are getting heavy, that is all right. You can let them close now. The sky will continue shining without needing you to keep watching. The auroras will move, whether someone sees them or not. The night glow will ripple gently in the upper air. The stars will continue their slow, ancient drift. You do not have to hold any of it. You do not have to hold anything at all. If you stay awake a little longer, that is all right too. Just let your breath fall into its natural pace. Let your thoughts pass through like faint meteor trails, brief and harmless. Let your body rest in whatever position feels easiest. This moment does not require effort from you. It only invites softness. When you wake again, the world will return. The decisions, the conversations, the bright parts of the day. But the calm you found here will still belong to you. You can carry it with you, quietly, the way the night carries its glows. And whenever you need it again, you can come back. The sky will still be here, patient and unhurried, waiting with the same quiet lights. If this helped you rest, or simply breathe a little easier, you are welcome to subscribe when you wake. It allows others to find this place too, and it helps this small corner of calm stay alive. For now, let your mind dim the way the horizon does after sunset. Let your body settle the way the atmosphere settles into nighttime stillness. Let yourself drift the way light drifts across the magnetic field. Rest well. Good night.